All right, in this video, we're going to find some indefinite integrals, and we're specifically going to do that with the power rule. So the power rule tells us that if we have x to the n dx, that turns into x to the n plus 1 over n plus 1 plus our constant of integration c. We could also write that as 1 over n plus 1 times x to the n plus 1 plus c, and I might write my answers that way sometimes, where this is the reciprocal of the new exponent. So add 1 to the exponent, multiply by the reciprocal of that new exponent, add a constant of integration on the end. We're also going to have some other rules that we'll be able to use when things get a little more complicated. For instance, if I have a sum or difference of functions here, then I can split the integral up like that. So I'm going to be doing some problems like that too. So make note of those properties. Let's start off with some basic forms here. Number 7, the integral of dx. This is an invisible 1 here. So that's going to be dx. That's really an x to the 0 dx. So that becomes x to the 0 plus 1 is 1 that I don't need to write. And then the reciprocal of 1 is 1 plus c. Let's take that and write 6 dx. I didn't tell you, but the integral of k times f of x dx is k times the integral of f of x dx. So constants can pass through as long as they don't have this variable there. So this is the same thing as this. So 6 times all of this is 6x plus a constant. You might think, well, 6c has to be different than just c, but it's not, because a constant is generic. 6 times a constant is still a constant. So this is a generic constant of integration. We do everything else first and add that constant of integration on last. Let's look at number 13. We have negative 9t squared dt. So it doesn't matter what my variable is. It just matters that this variable that's dt matches with the t's that are there. So I'm going to pull that negative 9 out front. Then I'm going to use my power rule to say this is 2 plus 1 over 2 plus 1 plus c is negative 9 t to the third over 3. And negative 9 divided by 3 is a negative 3, like so. Let's look now at number 15. And it says integral of 5 x to the negative third dx. We'll pull that 5 out front. And we'll use the basic power rule for integration. 5x to the negative second over negative 2 plus c. And I'll go ahead and leave that negative exponent because I started off with a negative exponent. I'll call this negative 5 halves x to the negative second plus c. It would be just as correct to call this negative 5 over 2x squared plus c as well. But if we start off with fractions, with x's in the denominator, let's end with x's with fractions with x's in the denominator. let's, if we start off with negative exponents, let's end with negative exponents. That's usually what the textbook expects from us. All right, let's make this video a little longer. We'll go ahead and find some indefinite integrals now that make us do a little bit of preliminary work, a little bit of breaking some things apart to simplify before we use the power rule. So x plus 3 dx, we're going to break that into an x dx and a 3 dx. So this is going to become x dx, and this is a 3 integral dx. So for x dx, that's 1 plus 1 over 1 plus 1. And this is x. We get a plus c on the end. So this is x to the second over 2, or I can call that 1/2 x squared plus 3x plus some constant of integration c. Let's go ahead and look at 27. 27 says the integral of the quantity of x to the 5th minus 8 dx is the integral of x to the 5th dx minus the integral of 8 dx. Very similar problem here. I'll pull the 8 out, just like I did before. And let's call this x to the 5 plus 1 over 5 plus 1 minus 8x plus c is 1/6 x to the 6th minus 8x plus c. Moving on to number 29. Number 29 is the integral of the quantity x squared plus 5x plus 1 dx will be integral of x squared dx plus integral of 5x dx plus the integral of 1 dx is dx. So this is going to be x to the 2 plus 1 over 2 plus 1 plus 5 times x to the 1 plus 1 over 1 plus 1 plus x plus c is 1/3 x to the 3rd plus 5 halves x to the 2nd plus x plus c. That was number 29. Now let's look at number 33 and 35 to wrap up this video. 33 is, we have a fraction here with 2x to the 3rd minus 1 in the numerator and x to the 3rd in the denominator dx. So we're going to split that up into two fractions. Like so. And then I'm going to cancel there. And when I divide like bases, I subtract the exponents, and 3 minus 3 is 0, leaving me with 2 minus x to the negative 3rd dx for my integrand. And then we're going to split this into 2 dx minus the integral of x to the negative 3rd dx. It's going to be 2 integral of dx minus integral of x to the negative 3rd dx is 2x minus x to the negative 3 plus 1 over negative 3 plus 1 plus c, 2x minus x to the negative 2nd over negative 2 plus c. Because I started off with a single fraction here, I'm going to try to get it into that form to finish up here. So let's clean this up a little bit. 2x plus 1/2 x to the -2nd plus c. Let's bring that exponent down here. And then we're going to work on making a common denominator. So I'm going to multiply by 2x squared over 2x squared. And that gives me 4x to the 3rd plus 1 over 2x squared plus c for my final answer for number 33. Now let's move on to 35 to wrap up this video. 35 says the integral of 5x plus 4 over the cube root of x dx. So we haven't really had one that would give us fractional exponents so far. We're going to get that this time. So this is going to be integral of 5 to 1 minus 1/3. That's going to be 2/3 plus 4x to the -1/3 dx. So it's going to be 5x to the 2/3 dx plus integral 4x to the -1/3 dx will be 5 integral x to the 2/3 dx plus 4 integral x to the -1/3 dx. So that's 5x to the 2/3 plus 1 over 2/3 plus 1 plus 4x to the -1/3 plus 1 over -1/3 plus 1 plus c. 5x to the 2/3 plus 3/3 over 2/3 plus 3/3 plus 4x to the -1/3 plus 3/3 over -1/3 plus 3/3 plus c. Five x to the 5/3 over 5/3 plus 4x to the 3 minus 1 is 2/3 over 2/3 plus c. Sometimes the book will leave things like this. I don't like that it does. Remember, when you divide by a fraction, you multiply by the reciprocal. So that's 5 times 3/5 x to the 5/3 plus 4 times 3/2 x to the 2/3 plus c. 5s will cancel, leaving me with 3x to the 5/3 plus 2 will go into 4 2 times. 2 times 3 is 6. X to the 2/3 plus c. Now remember, we had everything over a common denominator before of the cube root of x. So probably here, if I multiplied everything by the cube root of x and made this 3x to the 6/3 is 2 plus 6x to the 3/3 is 1 over x to the 1/3 plus c. That's probably closest to what the answer key is going to want. Just change that back to a cube root of x, and it looks the most like the problem that we started off with, though nothing is wrong from this answer here or this answer here or this. I would, as the teacher, probably, if I were teaching, prefer the answer that I put the asterisk next to because it's completely simplified. But we oftentimes with textbooks want to make the final answer look as much like the original problem as possible when we're doing integration. So there it is. And we'll come back next time and we'll just have a couple more problems to finish up in this section. Problems 43 and 47, where we're finding a particular solution next time. So see you for the next video.